On January 19, 2006, the New Horizons spacecraft was launched from Cape Canaveral, Florida. 9.5 years later, it flew near Pluto and provided stunning photographs. The scientists that say the universe is billions of years old expected Pluto to be covered with impact craters, but it isn't. Our guest today describes what all this new information reveals about Pluto. Coming up on today's edition of Origins, What's New on Pluto with Dr. Donn Faulkner. Hello, my friends, and welcome to Origins. My name is Donn Chapman. It's my privilege to be your host. During this program, we showcase interesting guests who present evidence from science along with other important facts validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. Donn Faulkner, earned graduate degrees in physics and astronomy and taught at the University of South Carolina, Lancaster for 26 years. He's been extensively involved in creation science, writing many articles and serving on the board of directors of the Creation Research Society. Several years ago, Dr. Faulkner retired as a full professor and has now joined Answers in Genesis in Kentucky as a full-time scientist and speaker. Welcome, Dr. Faulkner. It's great to have you back. You're an old friend here at Origins.
Thank you, Don. It's good to be back.
We're excited that you've come and you've brought us some fresh material to look at. And we're beginning with Pluto. Is that right?
That's correct.
So tell us what's new on Pluto.
All right. Well, Pluto, kind of is a mysterious planet to a lot of people. I think there are a couple of reasons for that. One of them is, people think he's named for a cartoon character.
Yeah. Which came first, huh?
Actually, Pluto was named first after the god of the underworld. The planet, I should say, or the former planet, was named first after the god of the underworld. And Walt Disney at the time was introducing a pet dog for Mickey Mouse, and he was looking for a name, and everything was Plutomania, so he decided to go with that.
He seized what was in the news and made it a character.
Yeah. However, there is an element named for the planet Pluto, and that's plutonium, element number 94.
Yeah.
This photograph we have here on the screen, that's a ring of plutonium used in a nuclear weapon. So. Anyway, plutonium is one of those heavy elements used in reactors, other nuclear parts of the industry.
So I'm just thinking, here's a planet that has notoriety. I mean, it's so popular it gets a cartoon character named after it and an element named after it. You would think it was in good standing, and then it loses its standing and is no longer a planet. How's that happen?
Well, what happened is Pluto's just really tiny. They were looking for some planet, really from the late 1800s up to 1930 when they stumbled across it. And from the beginning, they knew there was a problem. It's just very tiny. Well, it takes about 400 Plutos to make one Earth.
So it is very small, and that was the
low mass,
determining factor.
And Mercury is about 22 times more massive. So Pluto's very tiny, and we found other things out there in the far reaches of the solar system almost as big as Pluto is. So it's best to try to reevaluate that more as a minor planet or an asteroid at this point.
Okay.
And we have a photo here of made with the Hubble Space Telescope a few years ago, and it shows that Pluto has 5 satellites.
Wow.
We knew about Charon since 1979, and Charon and Pluto are close in size, and they had to put a mask, a blocker in front of this to catch the other 4. At the time they took this photograph, they only named 2 of them. The other 2 have now been, they're just called P4 and P5. They've since been named, by the way. We'll have another image for you in just a minute on those. Pluto is a bit mysterious. As you already pointed out, it's no longer a planet. It was a planet for many years, and I found over the years in teaching at the university, I'd ask people, what's your favorite planet? And the majority of the time it was Pluto.
Really?
And I think it was the fact that it was so mysterious because you see it's on the edge of the solar system, whatever you call it, a planet or not a planet. And being that far away, it's just a little smudge of light. You know, as a professional astronomer, I've only seen Pluto a couple of times through a very large telescope. It's just a little spot of light. And so we couldn't see any surface detail. And so getting information about it was pretty difficult. And really until 1979, we knew nothing about it when they discovered Charon that at least helped us develop ideas about its mass. And then a few years later, we got some information about its size and a little bit about the surface of the planet as well, or the object. Well, it still was a planet back then. However, you know, since the 1960s, we've been sending spacecraft to all the other parts of the solar system, and it remained the one lone planet that hadn't had a spacecraft visit it.
Because it's so much further away than the others.
Sending it out there can take years, as we're going to see, and it'd be quite expensive, actually.
Yeah.
We've kind of piggybacked several missions many times, going to more than one planet. It's all changed, however, in the last few years. You see, back in 2006, they launched the New Horizons spacecraft. And the New Horizons it took nearly a decade to get to Pluto. It's got to go about 4 billion miles to get there.
4 billion miles.
And it takes almost a decade, moving pretty fast to get there. Now, this was just a flyby mission. When it got to Pluto, it flew past and kept going. And they're actually planning to send it to an asteroid about another 3 years or so.
Still have control of it, still can make it go where
Still
they want it to.
operating.
Wow, that's
so
great.
anyway, it finally arrived in summer of 2015, and it's so far out the data stream takes a while. It took months, taking months to get the data back. Even images take a long time. We're not quite used to that, but being that far out, that is indeed a problem. And I have here, well, that's a photograph of the Earth's moon. And Don, you've probably looked at the moon before, and you can see the picture here. What do you think of when you think of lunar features?
Well, I know that's not cheese.
You know, it's not cheese.
But there are big craters there.
That's exactly right. That's what everyone thinks of when they think of the moon. Let me step to the screen and we'll talk about that a little bit. Don, we think that most craters on the moon came from impacts, and you'll notice the bottom of the moon, a region we call the Southern Highlands, has a large number of craters on it. But other areas, like up here, have relatively few. Now, it could be that all the craters happened to land, or all the meteoroids landed there, and very few up here, but that doesn't seem very likely, does it?
No.
So what we think happened is that there were craters impacting all over the moon, but then later on, volcanic eruptions came about here, covering the lunar surface, making it, wiping the slate clean, giving you a smooth surface, and only a few craters on top of that. And that's going to be very key as we try to interpret Pluto a little later on. So it's good to start with our own moon from there. Now here we have a comparison. The Earth is here, and this is all to scale. You see the little indications there. On the far left is the moon. Notice the moon is about 1/4 the diameter of the Earth. It's a lot smaller than the Earth is, obviously. Below the moon is Pluto, and this is just a scale for size. The Pluto is maybe 1/5 the diameter of the Earth, but has a far less mass, as I've already indicated.
It's slightly smaller than the moon.
Yeah, oh yeah.
Yeah.
And then we've repeated Pluto over here, same scale. We've also put Charon, its largest satellite. See how much smaller Charon is than our own moon. So that this size comparison gets across pretty well what's going on there. Now we also have a composite here showing the different satellites. Here's Charon, and you got Hydra, Nix, Kerberos, and Styx. And remember before we only had a couple of those named, and we've added a couple more since then. There's some rules about how they name these things, and it took a while to catch up, but now it's done. We have 5 satellites we know of, maybe a few more we don't know. And here we have the approach to the New Horizons. As it got closer and closer to Pluto, it took these photographs. Now some of these were taken pretty far out and the resolution's poor. Pluto rotates, takes about 6.5 days, and so we could only get one side of the planet, or the body I should say, as we got very close during that approach in the summer of 2015. This side particularly right here is the one we got up close. This not nearly as well. And this is one of the close-up photos, and Don?
Yeah.
Don't you just love Pluto? Isn't that?
It's a planet of love. Got that big heart on there. That's
former
amazing.
planet of love.
Former planet of love.
It's even kind of pink in this particular rendering. But do you notice anything unusual about Pluto?
Well, that jumps out at me that it's got a heart on it.
Keep
but
looking.
you know, the other thing you see is that it doesn't seem to have the craters that we saw on the moon.
There are a few. I see a couple here.
Yeah.
But this region down here has a couple. But you know what? They were
very sparse.
Yeah. They were expecting the surface of Pluto to have lots and lots of craters. It was quite a shock when it did. And we're going to talk a little later on the program why they thought that and what this means to us. And it's a very fascinating story when you get down there. But note again, very few craters on the surface. And here we have Charon, its satellite. And what do you notice about it?
Well, it seems pretty smooth except for the line kind of that goes through about 2/3 down.
Yeah, and you can see a few craters. It has
craters.
A few more, but there are vast regions that have very few or none. You know, again, they were expecting to be saturated, to be probably as dense as the lunar highlands, southern highlands on the moon. There's a large chasm running across like this. They've got a lot of stories they want to tell about that. But it turns out both Pluto and Charon have very fascinating surfaces. They expect them to be heavily cratered and to be very similar. Turns out they're not heavily cratered and they're very dissimilar. So it's an interesting place. Tall mountains on these things, by the way, very tall mountains. And guess what the mountains are made out of?
Rock?
Ice.
Oh.
Ice mountains. It's very cold there, so
Yeah.
ice is as hard as rock in many cases. Big surprise, Pluto, we had some hints, but now we know for sure Pluto has an atmosphere. This is looking through the planet, as it were, looking back towards the sun, taken from the back side after closest approach. And this is sunlight glinting through. Now, you do that with the moon, you don't see any light at all. That happens during a total solar eclipse. You don't see this glow around it. But you're seeing a glow there because light is bent through that atmosphere around it. You know, when the sun sets, it doesn't get dark immediately on the Earth because the Earth's atmosphere does the same thing.
Right.
Atmospheres do that. And by studying how that light comes through, you can actually infer some things about the structure of the atmosphere and even learn about its composition. I love this image here. We'll look at it again later on, but you can see the part of the terrain showing up on Pluto, some of the rugged regions of it. But you can see these layers of atmosphere showing up here all the way across.
Now, how many of the planets in our solar system have atmospheres?
Big ones do, like Jupiter and Saturn, but small ones like Mercury don't. And so Pluto can't really hang on to this atmosphere. We would expect the atmosphere to be dissipating. It'll be leaving because it's a gas and escaping because the gravity is so low. That too is very interesting, as it turns out, because why does it have an atmosphere? Where's it coming from? Why is it hanging around? So a lot of surprises. They knew there's some sort of atmosphere in Pluto, but not much of an atmosphere. Now here we have that heart shape showing up again, and this is false color, particularly this one on the right. They're trying to show you water ice concentration. You know, water is the most common molecule in the universe, and it has a relatively low density, about 1 gram per cubic centimeter. Rocks are 3 or more. And Pluto's density was about 2, or a little less than 2. So it's consistent with it being a mix of rock and ice, about a 50-50 mixture. Now some of those ices are carbon dioxide, which is usually dry ice, or methane, because it's very cold, as I said there. It's like 400 degrees below zero, close to that Fahrenheit. But this indication that there's quite a bit of water ice showing up. Some of this other ice here may be carbon dioxide, but all this blue you're seeing here indicating a concentration, actually more the green showing concentrations, higher concentrations of water ice. This may be more methane or something else showing up there. So a lot of ice, as we can see on the surface, various types of ices showing up. And some other interesting features we see. Down here you can see the heart feature right there. Down here's a little inset, and on this big wide field you see just a few things. This is magnifying this, and you can see it's kind of white topped. A few craters, but not many. And that white, we think, what do you think it might be?
Is it ice?
Yeah, it's ice.
Sure.
It's ice showing up.
Looks like that.
Yep, that's exactly what it is. And over here, this is a false color image, again indicating the composition and perhaps the texture on it. Exactly how that formed, what it is, we don't know. They've also inferred some glacial features. You know, across much of North America a few thousand years ago, there was a large glacier that moved across the surface. Thousands of feet thick. Where I live near Cincinnati, it was the southern end of that. And around the area, you can see many moraines where it dropped material. They've actually identified what they think are moraine deposits. So apparently Pluto once had glaciers, may still have some glaciers. Again, remember, it's very cold, so you have ice. It's very hard. When ice gets that cold, it's as hard as rock, actually. But some of those mountains that we see on Pluto are made of ice. And I find that fascinating because they stick up very high, thousands and thousands of feet, rivaling some of the heights of mountains on the Earth. And we wouldn't expect ice mountains to be that tall. How did they get that tall? How were they formed? Lots of questions we only begin to question and try to get answers for. We use the word geology. That really applies to processes going on the Earth. But we think similar things have happened on Pluto in the past. Now, being so far from the sun and being very cold, we expected Pluto to be geologically inactive. We didn't expect to be volcanic material spreading across. We expected soon after Pluto formed, no matter how it formed, it would just sit there and not change very much. And that's a key thing to the interpretation that's going on with Pluto. We'll talk more about that just a little later on. But there's a lot of fascinating geology. Nobody expected that. They expected a cold, dead world. Yeah. And that's the reason why they think craters should have been very common. I mentioned about the moon, regions that had lots of craters, regions that had few craters. A region that has lots of craters they think is very old or relatively older than the rest of the surface.
It's been a target for a longer period of time.
That's exactly it.
Yeah.
And if a place has been wiped clean, then through geological activity, then you expect to start all over again. Well, the thing is, you would expect on Pluto, if it's been geologically inactive because it's a dead planet, then it should have a very old surface with many, many craters on it. We don't see those. So obviously there must be geological activity. And that's where the fascinating part comes in, and where it comes into the question between evolution, creation, billions of years, thousands of years. So we'll talk about that just a little bit more. I mentioned some of these features up close here. We looked at this region earlier in close up. Here's another region just below the heart. And you can see these mountains sticking up. You can tell the mountains because the way the sunlight's coming in this way, it illuminates that side. It's bright, but then it's dark on the other side. This is in shadow right there. And here you have a depression showing up with a higher region right there. This is near the edge showing up there. So it's showing a lot of detail, a lot of vertical height taking place. And again, some of these features are showing up, they think, as glacial sorts of features. For instance, right here on the right on the heart itself, we know that we're pretty certain that this is some sort of ice, just from the spectrometry and the little false color image I showed you before. Notice very few craters. In fact, there's a kind of a crater right there, maybe, but for the most part, craters are missing entirely. You got some rugged uplands here, but this is perhaps been glaciated, or actually is a glacier. They indicate some subregions here they think are glaciers. They have some hill chains right here, right there, and right there, and those are very similar to what we call lateral or moraines on a glacier. That's the reason why they think there may have been a glacier moving across the surface. Kind of preliminary results here. I was shocked to learn talking about glaciers on a planet or an object like Pluto. Again, I didn't expect much geological activity. Nobody did. And as far as I can tell, this is the only body in the solar system outside of the Earth where they're talking about actual glaciers on the surface. And that's something we had never seen before anywhere else except on the Earth. And I find that very fascinating.
It is fascinating. It's fascinating to me as a layman to just see how much you can learn from one spaceship going by one time, and how you guys can get so much out of that. And then the uniqueness of this is fascinating. We're going to talk about it some more, but Dr. Faulkner, we have to take a break. Don't you go away. We'll be right back. Welcome back to Origins, my friend. We're talking with Dr. Danny Faulkner about Pluto. So we've got some interesting facts going here. We have an atmosphere, we have lots of iceous mountains, we have a smooth surface without any pockmarks or craters. What kind of implications are we seeing,
we can see it all here in this photograph. You can see the layers of atmosphere up here again. Showing up. They weren't expecting any kind of atmosphere because atmospheres are made of gases and they're moving very quickly. And Pluto doesn't have much of a gravity. It's pretty small, doesn't have a lot of mass. So the escape velocity is relatively low. Why hasn't the atmosphere escaped readily in the past is a question. It must be resupplied somehow, but how long can you resupply that and what's the source of that? Second of all, you see these mountains. These are really rugged mountains. They stick up a huge way on the surface of Pluto. Many of them made of ice, we do believe. And with time, you should have what's called hydrostatic equilibrium that works. Mountains poke up and they sink back down under their own weight. Many mountains on Earth are getting lower, as it turns out. I think the Himalayas may still be pushing up, but not by much. They're being pulled down all the time. And then look at this. Do you see any craters anywhere on the surface?
Not really. No.
Not this particular region. And again, I can't emphasize enough that they expected Pluto to be crater parked everywhere, saturated with craters, because they thought it was very old. and hadn't changed over billions and billions of years, so therefore it should have all these impact craters.
So, Dr. Faulkner, are you telling me there's indications here that it's very young?
Oh, yeah, I think that's the indication.
Yeah.
And, you know, I love this photograph. It's a real high-res photograph on the surface. It doesn't look like anything you would expect on Pluto. Looks like an ice sheet. And you got these cracks that kind of develop in ice sheets or in glaciers, and that's where some more ice or water, whatever the material is, comes up and freezes and seals back. You got this little feature here. Looks like a snail, doesn't it?
I was going to say, something's peeking up through the hole there.
We don't know. It looked like a snail kind of tracking along upper left to lower right, upper right.
Hasten to tell our viewers that it's not an animal.
We think it's a rock.
It's a rock, yeah.
But on top of ice.
Yeah.
But the thing is, this shows that there are glacier-like features on
Right.
Pluto. I think they're kind of putting question marks on it yet, but that's a real shock, real surprise. I didn't expect to see that sort of thing. So anyway, we can reach a few broad conclusions about all this. I would say, first of all, we would expect that from this that Pluto's surface is young. Remember we talked about craters, the fact that
Right.
Craters fall over some period of time. It's either going to happen over billions of years or thousands of years, depending on how old you think the solar system is. And so you would think that if something this far out from the sun is very cold, it's not geologically active to rework the surface, it should have lots of craters if it's billions of years old, as the evolutionists say. But if it has very few craters, that could be indicating that it's very young. Now, that doesn't mean Pluto itself is young. It may mean that there's been recent geological activity to wipe the slate clean. Remember, on the moon, there are places that are younger,
You said it
places
was
that are older.
volcanic activity.
Yeah. Doesn't mean that the whole moon is necessarily a certain age. It simply means that there are different regions that are different ages. And what we have to conclude on Pluto is that there must have been some activity in the past that wiped the slate clean. However, what would that source be? We'll come back to that in just a minute.
All right.
They're mountains, and as I mentioned before, they should be sinking under hydrostatic equilibrium, but they're still very tall. Even the weak gravity should do that, particularly if they're ice, but they're still very tall on Pluto. And then glaciers, this suggests geological activity, things moving across the surface. If you have, the glaciers don't do any good if they're parked still. You only see features showing up if they actually move across the surface. Now, you know, there are three ways that you can produce heat. It takes heat to make geological activity. One possibility is it's primordial. That is, it dates from the very beginning. But, you know, if it's just a few millions of years old, it should have cooled off by now. But most scientists think it's billions of years old, and so consequently, that's not an option. Another possibility would be radioactive decay, but you need heavy elements to do that. Pluto has low density. It doesn't have any heavy elements, so it can't be radioactive decay.
Scratch that.
And so finally, they've suggested tidal flexing. They've suggested that on a couple of satellites of Jupiter. The problem is you need a very massive body nearby. There aren't any, so there's no tidal flexing. Those are the three energy sources. None of them work. They're all eliminated. So the question arises, why does Pluto have all of those features we see? Well, the conclusion I reach, why does it have an atmosphere? I think it's being supplied, but it can't supply that for a long period of time, billions of years. That indicates a recent origin for Pluto and its atmosphere. The evolutionists can't explain all the volcanic feature, or I should say the lack of craters, because they don't have a heat source to explain all of that. And so my conclusion as a scientist, as an astronomer, and as a creationist who believes the Bible, is I believe the world is only thousands of years old. I think a little more than 6,000 years. And so when I look at something like Pluto, I would expect maybe that it's going to look very young to us. And it does look young. And so this is something we might expect with a biblical creation model that the world is not very old in. But if you believe in billions of years, as most scientists do, they have a difficult time. And even though it's been months, almost a year now since the space probe, they've been scratching their heads and no explanations have been forthcoming.
So there isn't even a dialogue going on.
If it is, it's going on behind closed doors. I haven't seen it.
You haven't been a part of it.
No, I've not, but I do believe they're tearing their hair out over this one.
You've looked at some very valid and serious scientific evidence. And like I said, as a layman, I'm always fascinated that we can have one spaceship go by a planet and we have this much data to work with. What a great time it must be to be an astronomer, to look at all of this.
Yep.
But the logical conclusion, not a forced conclusion, not you kind of shuffling the deck, but just an objective viewing of the evidence seems to indicate that it's not that old.
No, I think objectively we can say that, reach that conclusion.
Yeah.
Now, most astronomers and most scientists are not going to reach that conclusion because that's unthinkable to them.
Yeah.
So they're going to have to think of some other explanation.
So who's biased here? You're looking at the evidence and saying, but it points this way. And you're coming at it from three different directions here. You're not just saying we have this one piece of evidence and we'll build our whole conclusion on that, but you have three very sound facts that are very different from each other, not dependent on each other, and they all reach the same conclusion.
That's the whole package.
Yeah, you've done us a great service today. You've brought us information to help us learn and grow. And I hope that our folks hear this, and I hope it opens some minds and starts some dialogue, and will lead people to come to a conclusion that maybe it wasn't that long ago that God made the heavens and the earth. And so thank you for your service, and you have benefited all of us. You know, my friends, I want you to remember one thing as we conclude our show today. It's also God's view that He created you, and that should be your worldview too. We are so glad you've joined us. I hope you'll be back with us soon here on Origins. And until then, God bless you, my friend.
Thank you for watching this edition of Origins. For a DVD of this series, you can order online or send a $12 donation to cover shipping and handling and write to Origins Program number 1610, Cornerstone Network, Wall, Pennsylvania 15148. If you like a copy of the PowerPoint information presented today, you can download an episode guide at originstv.org.
Origins is made possible by the faithful prayers and financial support of you, our Cornerstone family.